Hello everybody, welcome back to the ASUS RG YouTube channel. This is JJ once again. We've got another overview and unboxing for you. This time around we're going to be focusing on the P9X79 WS series. This board is definitely one of the standout boards in our lineup. WS always takes a lot of time in terms of bringing something that's pretty unique to the market in terms of the I/O connectivity as well as the actual PCIe connectivity that's offered on the board, and this board definitely still maintains that focus. So overall, generally when you're taking a look at the WS series in comparison to the other boards that we offer within our portfolio, such as the channel series boards, mainstream like Pro, Deluxe, or Standard, compared to Sabertooth and the Tough series, or the Rampage 4 Extreme and the ROG series, WS is really focused at users that are looking at, one, a high level of PCIe connectivity. So they're generally looking at two-way, three-way, even potentially up to, as you can see on the box, four-way support, or also additional validation with support for different types of controllers or adapter cards, such as PCIe RAID card solutions, professional RAID controllers, higher-end network adapters, or a number of different other devices that are on the market that are in that kind of SOHO SMB space. But still, that being said, the WS is a great platform for a high-end enthusiast that's looking for a high-end system that, whether they're running at stock operation or at high levels of performance and under overclock configurations, the board will hold out well for you. So this board does pretty much meet all those levels, but definitely has a couple of key features that we're going to dive into that really help to focus it for kind of specialized users that are looking for leading connectivity, whether it's externally in terms of your I/O or on the PCIe side. So let's go ahead and jump on and take a look at the box and see some of the options that we have here. So as we lift up the flap, one of the key items that we see that's definitely consistent across our entire range of X79 series boards is our digital power control implementation. This is now our 6th generation of actually digital power control that we've implemented on boards, going back to our first boards featuring in an X58. And with X79, we're extending that control and that refinement and everything that we've learned, and not only now applying it to control options and power delivery digitally for the CPU VRM, but extending it to the DRAM. And this is giving us a lot of flexibility, helping to ensure more control options and flexibility, defining parameters for better stability, better performance, and reliability, whether you're running at stock or running at overclock parameters. So this is a key hallmark in terms of our X79 boards. For TPU and EPU, of course, those are our hardware-based controllers on the boards that we'll talk a little bit more about, but they help to provide specific options in terms of monitoring, as well as more granularity, whether we're talking about enthusiast-oriented options like auto-overclocking, or going with more conservative undervolt options for better power efficiency and lower temperatures on the EPU side. Of course, we have our leading Uefi implementation that's introducing certain new options that we have available to make things even easier for users. We've got our USB Bios Flashback. That's a great option for users that are looking for a quick and easy way to actually update the Uefi without actually even having to post the board or even put a CPU, memory, or graphics card in there. All they've got to do is connect the USB flash drive to the port and be good to go. We'll talk a little bit more about that when we actually take a look at the actual I/O. We've got USB 3 Boost, which is an exclusive technology helping to extend the performance for USB 2 and USB 3 devices, as well as for the latest generation of up-and-coming UASP USB 3 devices. We have our customized new hardware Super I/O controller, giving us more advanced controls via Fan Expert, whether that's within the Uefi or within the operating system under AI Suite 2, which we see here. The AI Suite 2 is pretty much a one-stop shop in terms of being able to access a lot of the advanced hardware that we have in the board, but real-time within the operating system. So it's the perfect combination of being able to have high-level controls, real-time within the OS that's working with the Uefi, our digital power implementations, and other options like our Fan Expert controls. And we've got a number of other items on here that, of course, that we're going to dive into, such as our specialized 3-color LED watchdog system, our diagnostic LEDs, some extra connectivity with ASUS SSD Caching, enhanced server compatibility, which we'll touch on when we look at the PCIe connectivity, and our quick gate technology, which are vertically raised USB ports, which are great for people in the professional environment. So after taking a look at the box here and some of those quick items, let's actually go ahead and crack this guy open and take a look actually at the board. First off the bat, we've got a quick stock guide. We've got the WS user guide and manual, which gives you a lot of information on how to set up the system and specification and setup guide parameters. We have the actual support disk, which gives you all the drivers and applications like AI Suite 2. Let's take a look at our SATA cables next. So we've got 4 SATA 6G cables. So that goes perfect. As we can see here on the board, we have 8 SATA ports on the motherboard. And we've got 4 SATA 6G cables here. And then we have 2 additional SATA 3G cables, 2 packs, so we have 4 additional cables. So that gives us actually a SATA cable for every single one of the ports. And then we additionally have here an actual Molex to SATA adapter if you're utilizing potentially a legacy PSU where you still need additional SATA connections for your hard drive. For professional users that might still be using specialized devices, whether they're COM-based maybe adapters, or maybe they're utilizing connections to serial-based printers or different types of devices like that, we have an actual COM header that goes to a serial port interface that would connect on the board. That comes included with that. We've got our Q connectors, one for the actual chassis power leads like power and reset, and then we've got the Q connector for USB. We have an extended SLI bridge for 2-way SLI support. We've got our Q shield. With our Q shield, like always, we have the soft padding to go ahead and allow for a smoother, softer installation, but as well as this, actually, Q shield offers enhanced protection against EMI, electromagnetic interference, because of course in our exposed backplane on our I/O, this area with more trace layout, not only for the 4 DIMM banks here, but also the I/O is more susceptible to different types of interference issues. So this helps to block interference from reaching this area, giving us better reliability, better stability. Here we additionally have a breakout cable header. So this actually gives us eSATA and then 2 additional USB 2 ports. So that's easy. You can go ahead and just run that connector, go ahead and run it to one of the actual SATA port headers, and then these 2 USB 2 headers, you can go ahead and run them to one of the integrated USB 2 headers here on the board. So that gives you some additional back USB 2 ports, and this provides to you the eSATA port for the back of the I/O. We have a 3-way SLI bridge. And then we've got one other item that comes included with the accessories for this board. And that would be a 4-way SLI bridge, as this motherboard does readily support single GPU SLI, which is 2-way configuration, 2 GPUs, 3-way SLI, and also 4-way SLI. So this is a custom 4-way SLI bridge, allowing you to go ahead and run 4 GPUs on this board natively. So that gives you a little bit of an overview on the actual items that come included with our WS. So let's go ahead and jump and take a look actually at the board itself and see what we have on here. So first and foremost, and definitely near and dear to my heart, I usually like to cover fan header connectivity. So let's take a look and see actually what we have here on the actual WS platform. So we've got 1 fan header, 2 fan headers, 3 fan headers, 4 fan headers, 5, 6. A total of 6 fan headers, just like actually our entire X79 lineup of boards. This is fantastic because especially with an enthusiast platform like X79, and especially with a high-end system like what the WS is really keyed in for, you want to be able to have the flexibility of being able to have control over a high number of fan headers so that you can optimally cool and configure your chassis. Now, especially in the situation when you have multi-GPUs, critical airflow control is going to be a key item. And as we can actually see here in the chassis in the back, we have kind of a normal enthusiast setup. We only actually have 1 GPU in there, but you can imagine if we had 2, 3 GPUs, we want to be able to really control and tune the actual characteristics of each one of these fan headers to ensure the best airflow. So you can see here we actually have one 120 millimeter, another 120 millimeter, another 120 millimeter, another 120 millimeter, and then one other 120 millimeter for actual Corsair closed loop H60 water cooling system. Now in this Corsair carbide chassis, this is really giving us the kind of ideal airflow configuration because we're getting great down firing airflows coming across our DIMMs, the VRM heatsink keeping this nice and cool, as well as actually bringing in air across our GPUs, and then of course the back of the chassis is exhausting out. But the critical item is that with our custom Super I/O controller on our board and the placement of the fans, we're able to give you per fan header control so that you can go ahead and customize it, whether it's specific to the chassis fan, to the front fans, top fans, or to the fans that are generally routed for either a normal, a CPU cooler, or like a closed loop water cooling system. So having that control and functionality is definitely awesome on this WS board. Now moving over to some of the other connectivity, let's go ahead and jump down here to the bottom and take a look and see what we have here. Now, at the bottom here, we have our a 1394 header. So you can see here that we have a header for that. Next to it, we actually have our TPU switch. Our TPU switch is really nice. This actually is independent of the normal overclocking functionality that's offered on the motherboard, but this actually works with the TPU chip that's actually on the motherboard. This TPU chip contains exclusive custom firmware that we develop that has algorithms that help define a quick and easy auto overclock, whether it's through our auto tuning option that's within the operating system or via executing the actual preset. With the preset, if you were to flip this switch when first turning on the system, it would give you a quick and easy overclock of about 4.3 gigahertz from your baseline. Remember that your baseline frequency is 3.6 under all 6 cores being loaded. So that's a pretty big jump to be able to do that with just a quick flip of a switch. Next to that, we have a clear CMOS jumper, so that in the event that maybe you push the board too aggressively, you need to go ahead and get the board back to default operating parameters. You can go ahead and just move that jumper over, clear it, and then go ahead and move it back. Moving over, we've got our COM connection, so that's for that actual COM header breakout cable that we showed, where you can go ahead and attach that and go ahead and run that out to the back. We've got a TPM, so that would be for advanced security functionality in professional environments. We then have the additional fan header that we already noted on. We've got our power and reset hard buttons that are here on the board. We have 2 USB 2 headers that are here on the board, which is great for front chassis or media card reader. Above that, we actually have our hardware debug code. So this is great for users that are a little bit more experienced and knowledgeable regarding debug code, so that when you're attempting to actually troubleshoot the system, find out maybe if there's an issue initializing the graphics card, memory, the CPU, a number of different variables, you can reference the actual debug code and resolve the issue and go ahead and get back up and running. Now, this type of diagnostic system works in conjunction with a number of other diagnostic options that we have on the motherboard. Take, for example, we have what's called our LED system. Our LED system is actually a lighting mechanism that we have right underneath this ASUS logo that, depending on the state of actually voltage that's being utilized on the board and the operating parameters, you'll have 3 lights that are indicating to you functionality. If we actually take a look here at the flap that we initially showed, we can see here that we actually have an indicator of that. So when we're in that EPU power saving operation mode, it would be in green. We're under the normal operating parameters, we're going to be under the blue. And when we're under a more aggressive overclocked environment with more voltages, we're going to be in that red mode. So it's a quick and easy indicator to let you know kind of the operational ranges that you have keyed into the board. Now, in addition to this actual LED lighting system, we also have what's called QLED. QLED is actually a set of LEDs that are sprinkled throughout the board. So we have one for the actual memory banks, we have one for the CPU, we have one for the VGA, and we have one for the boot device. These are key because they give you a more visual mechanism at actually being able to see where there might be an issue with the board when you're attempting to post it. Post reflects the power on self-test function. So when you're first setting up your system, maybe you don't fully seat the memory correctly, maybe the CPU is not fully seated, you forget to connect the header, maybe the VGA is not fully seated, you don't have the SSD attached, a number of different variables that come into play that what you can easily do is just go ahead and take a look and see, okay, the DRAM LED is locked, or the PCIe LED for the VGA is lit up. And you can go ahead and make your resolution, your adjustment, and be good to go. So lastly, as part of the diagnostic aspects that we have here, we also have, of course, our Memo K button. Memo K button up here is really key, especially when we take into consideration that we've done 8 DIMMs on our motherboard, which give you the most flexibility of being able to get to higher densities, whether it's 32 gigabytes or even 64 gigabytes worth of memory. On top of it, having the digital controls, which give us a lot of flexibility of being able to tune this for better reliability and compatibility, and a lot of the validation that we do on the Uefi side, there's still always a possibility, maybe if you're mixing and matching modules, possibly even buying the same 2 kits but at different times, maybe the memory ICs are different from one time of production to another time of production, you can run into issues. That being known, essentially if you run into a problem, you can go ahead and hold this button down, and what we'll attempt to do is auto-negotiate parameters such as the timings and frequency for the memory to go ahead and get the board working successfully. This also works great as a semi-clear CMOS, because what you can do is, instead of clearing the clear CMOS jumper, you can go ahead and hold this button down, reset frequency parameters, and be good to go. One of the key advantages of that is that you won't lose the rest of your settings, like maybe RAID configuration parameters, fan presets, and a lot of other configuration parameters that are independent of the overclock. So moving away from that and going over to the last connection that we have here on the bottom, we have our quick gate USB option. So this is a vertically raised USB port, and the cool option for this is that in a professional environment, maybe if you're a user that's utilizing professional 3D applications like Maya, Lightwave, different types of modeling programs like that, some of them will come with a proprietary USB dongle that can be fairly expensive. So instead of keeping that externally where maybe it could be stolen or it could be lost easily, you can just go ahead and mount that internally and always have the application reference the dongle and be able to initialize it quickly. I also actually like using this on my own system for my WS boards when I have them set up to have actually a USB flash drive that has all my drivers already on it. So I can go ahead and just plug that in there, and when I set up the system, I've got all the key drivers, any critical files, I save logs to overclocking parameters, all kinds of really nice stuff that I can just have in there, and when I boot up the system, bam, I'm good to go. I have everything I need to have. So this is a nice option in terms of giving you a lot of flexibility whether you're a professional user or an enthusiast user. So moving on to some of the other options that we have on the motherboard, independent of this bottom connection option and the feature options here, is let's take a look at what's really standing out on the WS, which is PCIe connectivity. With PCIe connectivity, that's really where it hits home for the WS series. We do a lot of validation in terms of not only testing standard configurations like CrossFireX, as well as SLI and the different formats that it supports, whether it's 2-way, 3-way, or 4-way, but also supporting more advanced options like FirePro graphics, which are the professional series of graphics cards that are offered from AMD. In addition to that, we also do validation with Quadro and Tesla cards, which are NVIDIA's professional solutions in that segment as well. So WS, that's one of the key parameters, in that these PCI slots, while they offer a lot of expandability, we're also doing a lot of back-end to do more validation. Higher-end controller cards on the market, like high-end RAID controllers, specialized network controllers, sometimes have their own specific option ROMs, which can sometimes have difficulties with standard BIOSes or even our standard UEFIs in terms of initializing supporting those devices. Our WS team takes more time to validate more of these devices to ensure a higher level of functionality, interoperability, and ultimately better compatibility so that you can use these devices and have them work correctly. Now, when taking a look at the PCIe connectivity, we can see that we're pretty much looking across the board and nothing but physical by 16 slots. So we've got one physical by 16, another physical by 16, another physical by 16, another physical by 16, one more physical by 16, and lastly, another physical by 16. So this is really going to be key for users that are looking for the latest generation of PCIe connectivity, whether we're talking multi-GPU configurations with high-performance RAID controllers, maybe PCIe SSD devices. This is really the board that speaks to you in terms of meeting that connectivity option with the demand that you're going to be placing on it. And in addition to that, you got a lot of flexibility in terms of the bandwidth configuration as well as optimal airflow. Even when utilizing 3 cards, which you're going to have, let's say, 2-slot card, and then you're going to have a 2-slot card, 2-slot card, you would still have expansion available to you. Or you could go triple slot, and then triple slot, and then still have additional expansion available. Or you could do 2-slot, 2-slot, and still have additional expansion available with optimal airflow. So this board is really an outstanding board for being able to give you a lot of flexibility for how you set up the board relative to your GPU and your expansion devices for PCIe. Now, moving away from that and looking over at some of the other connectivity that we have available here on the board, we can see that we have 8 serial ATA ports, which is great for a higher end board. So we've got the 6 PCH ports that are provided natively by the chipset, which here we have the 2 SATA 6G, and then we have 4 SATA 3G, and then we have 2 SATA 6G ASUS SSD Caching ports. The great thing with our ASUS SSD Caching implementation is that while the X79 chipset doesn't natively offer it, we're offering it to you to help expand the performance, the functionality of the X79 chipset. So one of the key parameters, of course, with this option that we offer is that one, that there's no need to actually enter into the Uefi and enable any type of RAID configuration. This is already at Uefi defaults ready. You just have to have your SSD, your hard drive attached. You boot up into the operating system, have ASU2 installed, you click one button, and it happens. It will initialize the actual SSD cache to RAID, even if you don't have your SSD formatted or partitioned, and there's also no capacity limit. So that's key, especially in a more professional environment, or maybe using this as a high-end gaming system, either environment where if you're limited to a smaller SSD like you are with SRT on the Z68 chipset, you can potentially run into issues that as you start to load in more games or more applications, you can bump out the previously cached application because there's not enough space to go ahead and keep everything actively cached. So the benefit of not having a 60 gigabyte limitation, you could utilize it like a Corsair Force 3 120 gigabyte or Corsair GT 120 gigabyte, something like that. Bam, you'd be good to go in terms of having much more space to cache everything over the long term of your usage of the system. So that gives us some of the SATA connectivity, and as we can also see, we've got right angle connections, so even as you have actually your GPUs, even at the longer end of the spectrum, they won't impact, and this still gives you good usability in terms of being able to do right angle connectivity. So the inside of your chassis, you got clean and tight cable routing. Now here we can see, moving up from the SATA, we've got a front USB 3 port. This USB port, just like our back USB ports, supports our advanced USB 3 boost technology. This is an exclusive hardware-oriented technology that works with firmware, as well as the hardware controller and driver, to be able to offer enhanced performance for USB 2 and USB 3 devices. So we'll go ahead and touch on that a little bit more when we look at some of the back ports as well. We've gone ahead and also have an EPU switch over here. This EPU switch, very similar to the TPU switch, is completely hardware based. It actually won't affect performance at all, and it's more focused for users that are looking at stock operation. If you're looking to have potentially a system that consumes a little bit less power, as well as runs cooler and more efficiently at either idle or low temperatures, the EPU switch is going to make it happen for you. This essentially runs a special undervolt algorithm where it tracks the actual voltages being supplied to the CPU, brings it down a bit, as I said, to go ahead and be able to bring down the actual overall power consumption, as well as give you a little bit lower temperatures. Now, moving over to the rest of the connectivity, we can see that we have an additional 4-pin Molex connection here. This 4-pin Molex connection is really going to be best utilized under heavy GPU configurations, or potentially when heavily overclocking the platform with the actual GPUs in place as well. And that's just to go ahead and provide additional backplane power to the system, stabilize it. But under most situations, it's generally not something that you're going to need to have actively connected for the board. Now, moving over to the last kind of key area that we can see that really stands out on the board is going to be the VRM heatsink area. So here we can see we have a very robust actual heatsink where we have a lot of fitting for dissipation, and we have an actual sintered heat pipe that runs from underneath the actual VRM heatsink into a secondary heatsink block, into another heatsink block that also then has a heat pipe that runs to the PCH. So we have a very extended advanced heatsink mechanism for actively cooling the platform. And this really works well, especially in these optimal configurations where when you're heavily overclocking the system, when you're pushing past 4.5, 4.6 gigahertz, you want to make sure this VRM is adequately cooled. So not only have we provided a very robust cooling solution, but when used in conjunction with like a chassis like this, where you have downward firing fans that can actively cool this, you're really helping to extend the overall efficiency and the power delivery of the VRM to be able to help solidify those higher level overclocks if your CPU is able to hold out. Now, in regards to what's underneath here, we definitely have some special elements. We've got our DigiPlus power control implementation. So this means that we have digital power control and delivery for the CPU VRM. So that means for the CPU as well as the actual key components like the actual phase array management, where we can control adjustment parameters, whether relative to temperature monitoring and balancing or current monitoring and balancing, as well as controlling things like the switching frequency or load line calibration. All these things can be readily adjusted real-time in the Uefi or within the operating system. And for this generation of board, we've extended this further by also including the DigiPlus controller for the actual DRAM, giving us the flexibility of really fine-tuning performance parameters and control parameters on how we're setting up the system, which is key when you're working with an 8-DIMM platform, as we noted before. In some configurations, because of the additional trace layout and the complexity of this side of the board, you might potentially need to be able to have more control to make modifications on one side that wouldn't necessarily apply to the other side. So being able to give you this flexibility is one of the key aspects of our dual intelligent processor design, where we have digital controllers for the CPU as well as for the DRAM, and that all works together, of course, with our EPU and TPU as well. Now moving over to the back I/O, let's take a look and see what we have going on there. With the back I/O, we definitely have a strong I/O set of connectivity that really speaks to a high-end system, as well as for users that are in the professional segment that need some legacy connectivity. So here we can see we have the standard legacy PS2 connection ports for both keyboard and mouse. Underneath that, we actually also have 4 standard USB 2 ports. Now, we also have an additional white USB 2 port with a BIOS button. What this actually is a special option that we call USB BIOS Flashback. So in the event that you need to update the Uefi when you're first setting up the system, all you need to do is go ahead and have a flash drive with the flash file on there, insert it into the port, hold down this button, and then from there it will go ahead and low level automatically flash the firmware and get it up to date. The great thing about it is that you don't even need the CPU, the graphics card, or the memory present on the system. All you need to have connected is just the 24-pin power and the EPS power connection. So those are the only two forms of power that are required. Now in the event that potentially you overclock the system too hard, or potentially maybe there's a surge or spike or sag, sometimes you can get occurrences that can corrupt the actual EEPROM, the firmware chip. If that were to occur, you can also attempt to utilize the same mechanism to overwrite the firmware, get it updated, and get back up and running, saving you from having to RMA the board or remove our replaceable ROM chip and ship it back for replacement. Moving down from here, we've got a Toslink and optical output connection. Then from there, we have two additional USB 2 ports, and then we have an Intel Gigabit Ethernet connection. Now, the great thing about the WS board, as you can see here, is that we have dual Ethernet. But even better is compared to our deluxe board, which has one high-performance Intel native Gigabit Ethernet, and then a secondary solid performance Realtek network controller. We're actually offering dual Intel Gigabit Ethernet on this board, with one of them being the LCAS server grade connection option. And this really speaks to users that are having a more professional work environment. Maybe you're running gigabit networking at home, you're utilizing this in a server workstation environment, high performance running out to a high performance router configuration, maybe a Windows Home Server box, or a high-speed router where you're doing online storage, different variables like that. It gives you a lot of flexibility. With the Intel class of adapters, you're going over to a higher performing NIC, generally lower CPU utilization, overall better performance, better compatibility, and better interoperability with different types of applications or OSs. And one of the really cool options is definitely some of the advanced options that you get in Intel's advanced network management options, which are present within their drivers. So moving down from the rest of this connectivity here, we've got two more USB 2 ports. We have a legacy 1394 FireWire connection, and then we've got two USB 3 ports here, which give us a total of 4 USB 3 ports, which is great. Now these two USB 3 ports, just like our front header, utilize our USB 3 boost technology. As we noted earlier, this gives you the ability to enhance the performance for any standard USB 2 or USB 3 device. Normal USB devices run in an operational mode referred to as BOT, which is a legacy standard protocol transmission. It works, but it's not very effective at taking advantage of the higher bus operation that you can have with USB 2 and definitely USB 3. Now with this option, what we can do is we can transition into supporting Scuzzy operation mode, which is newer and more advanced than the standard BOT operation mode. Scuzzy, while not as advanced as the latest generation USAP mode, will still give you lower CPU utilization, higher throughput, and offers some queuing functionality as well. This overall helps extend the performance for either a standard USB 2 or a USB 3 device. Where things get really interesting though is if you have a UASP USB 3 device. These devices can see significant performance increases, sometimes extending performance over 100 megabytes on read and write performance, when you match that up with our USB 3 boost ports. So definitely a pretty cool option in terms of extending the performance for USB 3 or USB 2 devices. Here we have that secondary Intel Gigabit Ethernet controller that we mentioned. And then here, lastly, we have our standard 7.1 multi-channel audio. Now this pairs up with our standard Realtek 892 codec controller, which is also utilizing our new DTS Ultra 2 PC package, which also gives us the ability to do full real-time multi-channel encoding from 2-channel content. Main benefit with the DTS packaging is that we use a lower compression rate as well as we have a higher bit rate for encoding. So that's a great option for users that are connecting out to a digital speaker system or a receiver looking to get a higher quality encode. So that overall gives you a little bit of a kind of an overview relative to the WS, some of the specific features and functions that this platform has to offer. If you're definitely interested in finding out anything more, definitely drop us a line here in the comment section on the YouTube page, or make sure to head over to the ASUS ROG forums where we'll have more information on the board as well as additional performance information. So thanks for watching.